And welcome to the channel Let's Learn Electronics. In our last video we discussed the topic of Shockley's equation, how it mathematically defines the physical behavior of a graph and its characteristics curve. In this video we will talk about diode's resistance. We have seen this characteristics curve many times in our previous videos. We know how it is formed when we apply a certain voltage which is input to the diode, we get a corresponding current. We keep on changing the voltage. With a new voltage value, we get a new corresponding current, and this way different points are plotted on the graph, and collectively those points make this characteristics curve, this non-linear characteristics curve, which defines the physical behavior of a diode device graphically. We have seen this concept in the previous video. If you are confused, please visit our channel and watch the previous videos to understand it better. Anyways, moving ahead, when every device offers some kind of resistance. So here in case of a diode, to calculate that resistance, we know the voltage, we know the current. For using the Ohm's law, we can easily calculate the diode's resistance. It depends what kind of input is what kind of voltage is input to the device. We'll talk about it in the next slides. As of now, just remember one thing: as this operating point moves from one region to another region, the diode's resistance also varies. When we have a less voltage input to the device, when we have less current flowing through the device, obviously the resistance would be high. In this region the resistance would be high, we'll have less current flowing through the device. And when we keep on increasing the voltage, when more current is flowing through the device, the resistance drops down. Here we'll have less resistance because the current has increased. We know the relationship between voltage, current and resistance. We know that Ohm's law equation. Following that, we can easily calculate the diode's resistance. Now, this diode resistance basically depends on the type of input voltage which is available to the device. For example, in case 1, we have a definite DC value. We know that DC voltage is fixed. It won't change according to the time. So this case 1 is the basic one when we can easily calculate the diode's resistance. Case 2 would be the alternating voltage value when the input voltage would be an AC one. So we know that alternating current or voltage changes with time. So this operating point would be shifting according to the input voltage. We'll talk about this case 2 in the next lecture. In today's lecture, we will only discuss the concept of input DC voltage. When this DC voltage is input to the diode, how can we calculate the corresponding diode resistance? This kind of resistance is simplest to calculate because we have a definite value of input voltage, a fixed one. It won't change with the time. We can calculate the corresponding current. When some voltage is applied, we can calculate the corresponding current on the graph easily. And we know both the values, we can calculate the corresponding DC resistance. For example, we have a definite value, an applied DC voltage, and we'll get a corresponding current value. We know these two values. The best part is that in this case, these values are fixed. They won't change with time. We increase the voltage, we will get a new voltage input voltage value, we will get the new corresponding current value. We can calculate multiple readings on the graph. Now let's consider a numerical or an example. When we need to calculate the DC resistance level at a fixed point, we are asked to calculate the DC resistance level at 2 milliampere, for example. Let's consider this case 1. Let's assume that we know here is the 2 milliampere. We know the corresponding the applied voltage. Here we have 0.5 volts available to the diode device. We know the fixed value of DC voltage, the current, both the values are fixed. Using Ohm's law, using this formula, we can calculate the resistance at this particular operating point. RD is equal to this D denotes DC resistance. Everything is in capital, that is why. So putting the values in the basic Ohm's law equation, we can calculate that 250 ohms is the resistance, DC resistance at this point on the graph. Then we consider the case 2. Here more current is flowing, 20 milliampere is flowing in the device. The applied voltage is 0.8 volts. Using this graph we can calculate, or we can measure that okay, the applied voltage is somewhere around 0.8 volts, and we put the values in the equation. We will get a new DC resistance value. This is 40 ohm. So we can observe that at this point, operating point, the DC resistance is 40 ohms. The device offers less resistance at this region or operation because we have more current, and the device offers more resistance. ज़्यादा resistance होगा इस region में near the cut-in voltage or before the cut-in voltage, because less current is flowing through the device. Now let's consider the reverse bias region. We know that during the reverse bias operation, the diode offers maximum resistance. The diode does not allow the current to flow. Negligible current is flowing through the device. So this is a high resistance region of operation. And let's consider one more numerical in this place. In this example, we are given two values. The applied voltage is, let's say, minus 10 volts, and the corresponding current is minus 1 microampere. We know these two values. The good part is that it's fixed. Just put the values in the Ohm's law equation and we'll know that 10 mega ohms, such a high resistance value, is being offered by the diode during the reverse bias section at this corresponding is at this operating point. This way DC resistance is calculated in a diode device. So must remember that lower is the current flowing through the device, higher would be the DC resistance level. We'll talk about the AC resistance in the next lecture. So stay connected with us. If you want to connect with us, then this is our email ID. Please drop us an email if you are preparing any assignment and you need any assistance in writing your projects or report. Then please drop us an email on this ID. We'll get back to you. Thank you for watching the video. Like it, share and subscribe to